Good evening, ladies and gentlemen. I will be doing equations, and I will be doing them from the first three chapters. First chapter, of course, being how to make variables the subject of the formula. The second chapter being, the second section being how to work with univariate equations. The third chapter being bivariate linear equations. And now, bivariate linear equations, as I have written there, it's simultaneous equations. Now, what we'll be working with, of course, are these three, but there is, of course, one last section, but I've decided to leave that section to stand alone. So, we will start with making the variable the subject of the formula. So let's jump in. Now, the making of a variable the subject. Now, we need to go back with BODMAS. Now, remember BODMAS, we were told in our junior secondary school that BODMAS stands for brackets of division, multiplication, addition, and subtraction, which basically means that when you work with BODMAS, you start with brackets. You follow with division. After you dealt with the brackets, the first operator you deal with is division, the division sign. Anything that divides, you deal with that first. And then you go to multiplication after division. Then the additions and subtractions then follow. Whether with addition and subtraction doesn't really matter whether you start addition or subtraction, but they all follow. Now, with equations, of course, BODMAS works with when you want to simplify something. So we're simplifying mathematical expressions. That's what we work with BODMAS. But now, when we're talking about equations, on the other hand, we reverse the BODMAS. Rather than starting with brackets and ending finishing up with subtraction, we start with subtraction and deal with the brackets last. So we start with the most outside and coming back inside. So we'll see what we mean, of course, when we start with the furthest to the nearest. The variable of concern is what we are looking at. So we start with the furthest values and then come closer, work with subtractions, additions, multiplication, work closer and closer and closer up until we reach, of course, the variable. But of course, I'll explain that later. Now, we do reverse what I call reverse BODMAS. So, our reverse BODMAS is the way we'll be using to deal with solving equations. It's not in general that every equation will be solved like this, but for linear equations, which is what we'll be dealing with, this is how we'll be solving the equations. So, before we jump right in, we've got what we call an equation. And we need to understand, what do we mean when we say we are talking about equations? What we mean is, or the definition of an equation is a statement that values, or a statement that the values of the two mathematical expressions are equal. What does that mean? It means you will have two mathematical expressions. They are expressions for as long as they are just there. Up until these two mathematical equations are separated by that equality sign. Up until it is separated by that equality sign, it is not yet an equation. Only when we include that equality do we then get an equation. Another definition, which basically summarizes what we've written above, would be the process of equating one thing with the other. Now, what does this mean? This means that if you have this means that if you have 8x plus 4, and then here you've got negative 7xy plus 8. This is an expression, this is an expression. Up until we have equal to. Up until we have equal to, they are not, if we don't have this equality sign, these are just two expressions. And there is no relationship between these two expressions. This is one expression, this is another expression. And then this equality then joins these two expressions together. And by doing so, by adding this equality sign, we now have an equation. That's basically what the definition I was showing you means. Now, the basic linear equations. Now, a linear equation will be thoroughly explained when we do univariate equations. But basically, a linear equation is an equation where the variable is multiplied, first of all, by a constant coefficient, meaning it must take some number. We may not know what the number is, but it must take some number. And there must be, and the variable or variables, if we're talking about many variables, the variable or variables should be multiplied by a coefficient, and the variables or variables should have an exponent of 1, meaning we are not expecting roots, we are not expecting other types of exponents, we are only expecting the exponent of that particular variable or variables to be 1. But I will explain that when we reach the equations part. So let's say we have this. Sorry. Now, the objective here is to make B the subject. Now, let's paraphrase this through. We're saying that the first thing we need to do is remove that C. Now, what does that mean? Let us explain. What does that mean? Why do we need to remove that C? Again, let me explain. I will explain it like this. Let's say you've got 7 plus 3. Now, of course, we know 7 plus 3 is equal to 10. This is an equation. We are finding a relationship between 7 plus 3 and 10. Without the equation, these are just two equal numbers. So these are just two mathematical expressions. Now, what we're saying here is we would like to make this 7 be the subject of the formula. What do we mean when we talk about the subject? When we talk about the subject of the formula, we are saying we would like 7 to be the only value standing on one side, while everything else that does not have 7 stand on the other. So what does this mean? If you want to have 7 stand alone, we need to remove the 3. But how do we remove the 3? Now, to answer the how, this is what we do. We have what we call a, let me write it here. We have what we call binary operators. This is what we do. We have what we call binary operators. And binary operators, you get a plus, it's a minus, it's a times, it's a division. Or these are the basic binary operators. Binary operators meaning they take at least they take two numbers and they mash them together to get one number. That's why they are called binary operators. Their operation is to add, if we're talking about addition, minus, or time, or divide. But they operate on those two numbers to get a single number. They take two numbers and get a single number. And they're binary because they are always going to be in between two numbers. They're never going to be in between three numbers. They are always going to be in between two numbers. But of course, binary operators, we are not doing that kind of mathematics today. We are doing a different kind. So we have what we call this binary operator. Now what we have with these binary operators, they are arranged in such a way that the opposite of plus is minus and the opposite of minus is plus. Even here, the opposite of multiply is divide and the opposite of divide is multiply. What do I mean? If you have positive 2, how do you remove this 2? Remember, opposites mathematically, not in physics, for those who study physics. In mathematics, when you have two things that oppose each other, they cancel out. If I'm pulling something and then someone else is pulling that very same thing, we're at opposite ends. So we end up doing nothing. So if I have a positive 2 and then I subtract that 2, then what do I have? Nothing. If when it comes to multiply, this is what we call an additive identity, but different mathematics. Now if I have a 2 and then I want to remove this 2 such that whatever multiplies this 2 does not change. 2 over 2, I have to divide this 2 because remember the opposite of times 2 is divide by 2, or the opposite of times 2 is to divide by 2. What do I get? A 1. Remember, anything multiplied by 1 does not change. Anything added by 0 does not change. So these are what we call identic numbers. This one is additive, this one is multiplicative, but we are not doing that kind of maths. I'm just explaining why we need these equations. And then once we are done with these equations, what we want now is to, basically what I'm explaining here is we want a number, if it's positive, it must oppose that positive. Every positive number is opposed by a negative number, and every multiplied number is opposed by that dividing number. So we want now a number that opposes 0 so that we are left with nothing. We want a number that opposes 3 so that it removes a 3. The only way to remove a 3 is to, since we've got a positive 3, we want the opposite of positive 3 is negative 3. And remember on this side, what do we have? 10. We've done nothing on that side. So 3 minus 3 is 7, which is equal to 10. Now we know this to be equal to this. We know 7 plus 3 to be equal to 10. But is 7 still equal to 10 if we remove the 3? And the answer is no, it is not. So because it is not, what do we have to do so that we have this left-hand side being equal to the right-hand side? Because right now they're not equal. So if we're side equal to 10 and we want these numbers to be also equal, and we want this 7 to stand alone, if we subtract 3 on this side, we must also subtract it on this side so that we maintain balance. The equation should continue to balance. Now 10 minus 3 is 7, and 7 is equal to 10 minus 3. And that is why it is important for us to do, if we do something on the left, it should also be done on the right. So that's why it's very important, because if you don't do it, if you do it on the left and not on the right, you will be changing the value of the equation. That is, you'll be making the equation to have no balance. Another example we may take is, what happens 7 times 3 is equal to 21. This is what we know. Now 7 times 3 is equal to 21. We want to make this 3 stand alone. How do we make the 3 stand alone? We need to remove this times 3. It's very important to note what the binary operator is, isn't it? So we need to remove times 3. And how do we remove times 3? We divide. Anything, what is the opposite of multiply? It's divide. And if we divide that, these 3 will make 1. What is 1 times 7? 7. So 7 is now standing alone. And we've done nothing on the right hand side. Now, we know 7 times 3 to be equal to 21. We do not dispute that. Now the question is 7 still equal to 21? If we remove the 3, is the left hand side still equal to the right? And the answer is no. So which means in order for the right to be equal to the left, we need to divide by 3, which is the same number that we divided by on the left. So again, it elaborates or further explains why it is important to do what you've done on the left to be also done on the right. What you do on the left should be equally done on the right in the same manner. If you're multiplying the whole left, you should also multiply the whole right. If you're adding 1 on the left, you should also add 1 on the right. But remember, when you do this, you don't do it to a particular number. For instance, if you have 2 plus 3, let's say squared, it will be, of course, and it will be 5 squared. When you are adding, you are not adding on a particular something. You are adding on the whole side. So if you're going to add 2, you add 2 here. Remember, when you're adding on the whole. This is the left hand side. This is the right hand side. When you're adding on the left hand side, which means you have to add on the right hand side. But if again you're given this kind of question and you say, no, I just want to add I want to add a 2 here, this is not allowed. This is the left hand side. This is not the left hand side. This whole thing is the left hand side. So when you add on the whole side, not on the portion of the side. Because here, by adding on this 2, you are adding on the portion of the side. And if you were to add 2 here, because this 5 is already complete, unlike the 2 plus 1. So if you add 2 here, you'll find that you have 27 on this side. But here, You don't have 27. What do you have? You have two. This is a 4, 7. You've got 49. 49, and you've got 27 on the side. And these two numbers are not equal. That's why I'm saying it is important that you understand when you are adding or multiplying, you are not doing it on a particular side, on a particular part of the side. If you're adding on the whole side, so that whatever you add on the left should also be equally added on the right. If you're multiplying, you're not going to say, I'm going to multiply this 2, but there's no 2 here to multiply on. So when you multiply, you're not multiplying on the particular number. You're multiplying everything here. And so that if you're multiplying all of the left, it is easy to multiply all of the right. I hope you guys have understood this part. Now, let's go back. Now, we've got AB plus C equal to E plus F. We want to make B the subject of the formula. And first thing, we want to remove the C. Remember what we said with BODMAS. Instead of, remember, BODMAS says brackets, division, multiplication, addition, subtraction. We've got no subtraction, so we don't need that. But we do have addition. Let's focus on the addition. Because now we're taking it from the tail to the head, instead of the head to the tail. So we don't have subtraction, but we do have addition. Now, with addition, we need to remove this value, because if we're taking BODMAS from reverse, it will be subtraction, addition, multiplication, division. And then we look at the brackets, if there are any. In our case, we have no brackets, but we do have addition, and that's where we will start. So we need to remove this adding number. Now, this adding number is positive. This adding number is positive. So how do you remove a positive adding number? You include a negative number. So that we have plus C minus C equal to 0. Remember, the objective is to make B stand alone. And whatever, if we subtract C on the left, we also subtract C on the right. Now, I want you to note, we did not subtract C on C. We subtracted C on the left. Remember, this is the left-hand side. And when we subtracted on the left-hand side. This is the left-hand side from here. Now, we subtracted from the left-hand side so that we're able to subtract from this right-hand side. Okay. And then, after we've subtracted, we are left with that equation on the left and that equation on the right. Now, after addition, taking BODMAS in reverse, we now have multiplication. Now, multiplication, is there multiplication? Yes, there is multiplication. And what do we want to make the subject? B. And what is multiplying? A. It's multiplying what? The B we want to make the subject. And what is the opposite of any multiplication? It's division. So we divide by A. And whatever we do on the left, we do on the right. And again, remember, what is the left-hand side? This is the left-hand side. This is the right-hand side. So when we divide all of the left-hand side and all of the right-hand side. We don't just divide, we don't just divide the left and then divide maybe only E or only F. We divide everything on the right, just like we've divided everything on the left. So we are then left with B standing alone. Now, taking reverse BODMAS, there are no brackets, there's no division. And automatically, after we've done our division, B stands alone, which means we have now made B the subject of the equation or the subject of the formula. Now, let's take another more complex example, but within the range of our example. We've got this C into A plus B plus E. Then we've got this C. Now, let's start this from the beginning. The objective here is to make C the subject, but here's what we have. Now, when making C the subject here, it's important to remember. It's important to remember that everything, once we make C the subject, there should be nothing on the other side with C. Otherwise, if there is something with C on the other side, C is not yet the subject. Now, what do we need? We need to make C the subject. So, first things first, everything that has the variable of concern, and the variable of concern or the variable of interest is C, which is what we want to make the subject. So we take everything with C on one side and everything without C on the other side. And because I said we're dealing with linear equations, all these other terms, they have C in it. Therefore, we can take C out as a common factor. But now here's the question. How did we get that bracket? Let's go with how we got the bracket. We've got C into A plus B plus C minus FC equal to D plus 2. This is the question. Now, we want to take C out as a common factor, but we need to understand what does it mean to take something out as a common factor. That's what we need to understand. Sorry. Now, what it means is I'll say to take out the let's say you've got 2x squared minus 3x plus z squared x cubed. Let's say you've got this. Now what do we want? We want to take out x as a common factor. That's what we want to do. We want to take out x as a common factor. So how do we go about this? First of all, what are we taking out? We're taking out x. So we automatically put x here. The one we're taking out should be put out. But how do we work with the ones that remain inside? First of all, this is how you do it. We say term. The term are these values and their signs. we say term over common factor. That's how we say term over common factor. That is how you take out what is this thing? The common factor. Now, what do we have? We have 2x squared, which is the first term. We divide it by the common factor, which is x. And what do we have? X and x squared, they cancel one another, and we are left with 2x. And we have 2x. What's the second term? We've got 3x negative 3x divided by x, and what do we have? Negative 3 minus 3. And then third term, we've got positive z squared x cubed divided by the common factor x. And 1x cancels, 2x is here, and we are left with z squared x squared. And we've got positive z squared x squared. And that's how you remain with the terms inside. Now let's go to the actual problem we're trying to solve. The objective takes it out as a common factor from here. And what are you left with? You've got c over a plus b all over c, which is equal to a plus b. We can keep it in brackets, you can keep it out of brackets, it doesn't really matter. Second term, we've got a positive c over c, and what do we have? C and C cancel one another, and you have 1 minus f over c over c. These two c's, they cancel one another, and you're left with negative f. Then you've got minus f. And this is how you will get the terms inside the bracket that we will see shortly. Okay. And then we get those terms which are right here. So now remember, I said anything that using reverse BODMAS, C is the variable of concern. So that bracket, all of that bracket is now multiplies C. When we take C out, all of that bracket now multiplies C. And if it multiplies C, just like we did with A when we're solving for B, or we make it be the subject, we can now do with the whole bracket instead now. And then we divide by the whole bracket, and we get what we get at the bottom. Now, let's extend it further. We've got these nonlinear variables, of which, of course, we will be working with them a lot when you're doing financial mathematics. But for now, we're just going to learn how to make nonlinear variables the subjects of the formula. So we have A is equal to P into 1 plus I all to the power T. Bracket to the power T. And the objective is to make I first the subject. Now, here's what you do. First of all, before we go to the division, remember, reverse BODMAS. Is there subtraction? No. Is there division? No. Is there addition? No. Sorry, is there subtraction? Is there addition? No. Is there multiplication? Yes. Reverse BODMAS. No S, no A, but we've got a P. Now, remember, now when we're working with such variables, let me just explain something. When we're working with such variables as this, how do you solve it? Now remember, with BODMAS, we start with here. Is it available? No. Okay, let's move to the next. Is it available? No. Okay, let's go to the next. Is it available? And then we continue to do this. And if it's available, we work with it. But if it's not available, we jump into the next. Now, remember with variables, we work from outside in. If you remember what I said in the beginning, I said with variables, we work from outside in. You start with the furthest from the variable to the nearest. Now, this reverse BODMAS works with the furthest. Let's start from the furthest. Is the reverse BODMAS applicable? Okay, no. Here, the furthest, there's nothing furthest than P. The P is the furthest, that is the most far from the variable of concern, which is I. So, since it's the most far, we then look at our reverse BODMAS. Is it S? No. A? No. Is it M? Yes, it's P, which multiplies. So what do we do? What's the opposite of multiplication? Because this is the variable we want. This is the variable of interest. So what do? We divide throughout by P, so that this P cancels and we're left with 1 plus I alone on this side. And here we're left with this variable. And then, again, we've got, now that we're done with this, we look which one is now the furthest. But now, this is the variable of concern. So the furthest here is T. So how do we work around T? T is an exponent. Now remember, this is an exponent. How do you remove this exponent? You multiply by the opposite of that exponent. If it's 2, you multiply by 1 over 2, which means you will have, x. The exponent is now being removed. But what does 1 over n mean? 1 over n, you remember from your exponents, we said n, a to the power n is the same as the nth root of a. This is what we said on our exponents rule, I think grade 9 to grade 10. We are talking about this rule when we are dealing with size and indices. Remember, this is the nth root, not n square root. Remember, not. This is not n square root. There is a difference between the cube root of 8 and 3 square root 8. I will show you on the calculator. If you were to use, we have 3 square root 8. This is the answer. Okay, 6 root 2 or 8,485, yada yada yada. Now we have the cube root. Now notice how small it is compared to 3 square root. Notice how small it is, indicating that it's a root. Also notice even in my writing, cube root is smaller, but 3 square root, the 3 is bigger than 3 square root. Because the root is not 3, the root is 2 when you're talking about square root. So cube root of 8 is 2. Now you will notice the difference in answers. Smaller, bigger, smaller, bigger, because this indicates that it was, of course, the 3 is not a root, but in this case 3 is the root. So you have to make sure when you press the calculator, you should press shift, and then you press, if you're using this type of calculator, this here, so that you can have your 3 and your 8 and you got the 2. This is, of course, this function is general. Maybe you can put in the 10th root of 7, it gives you this value, and so on and so forth. But of course, we'll be dealing with this in depth when we're doing financial mathematics. But I was trying to explain what we mean when we say we're taking out the root. So when we take out the root, we find the 10th root. If it was n, it would be the nth root. If it was m, it would be the mth root. But because it's t, we say it's the 10th root, meaning if the 10th root of this value will give us what is inside. Remember, the nth root of xn gives us what is inside, which is what happens here. And then what we do on the left, we also do on the right. So we've got the 10th root of a over p. Now, what is the furthest? After we remove 2, which one is the furthest from I? It's 1, and we take out 1 this side, and then we're left with I and 4. Now you can leave it like this, or you can leave it like this. It doesn't really matter. Now, here I was trying to explain why we are going to do what I'm going to show you right now. So I said we divide by p, and 1 plus I to the power p. Remember, I just simply rearranged it. Remember, I said you can keep I on the left and keep I on the right. As long as I is standing alone, doesn't really matter which side you decide to put it in. Now, because p is the furthest, again, so the t is now the furthest from I compared to 1. T, we find the 10th root, and the 10th root is like that. And then 1 now is the one that remains. And then the solution of I becomes like that. Now, if we was to make t the subject, we've got a over p. Again, the furthest from the variable p, it's not I, it is p. So the furthest from t, it's not I, it is p. So we divide by the value which is the most further, which is the most far, or the furthest from the variable, and then we divide by p. Now, here's the problem. We now have t. We have t. What are we going to do with t? We cannot solve for t as long as t is the exponent. So what do? We need to find a method such that this particular method allows us to make t a variable we can make the subject. And which method allows us to do that? It is, of course, logs. Logs. We need to introduce logarithms. Now, in our lecture, of course, I did explain the relationship between log and lim, but this time I'll just stick to one story. We want to introduce log, and this log we will call ln, or written as ln, not in. This is wrong. It's ln, ln. Now, what is it with ln? Ln, we've got log rules. Let's call them log rules. The log we're talking about are logarithms. It's nothing else. So log a, or ln a to the power b, remember you keep this inside the bracket. Ln alone does not work. There must be some number inside ln. And what do we have? We have b times ln a. Now let us put that in a test. Let's say you've got ln 3 squared. Is it equal to 2 ln 3? Let's test. Ln 3 squared. Sorry. 2,197224577. Let us test 2 ln 3. Don't forget to close the brackets. It gives us the exact same value. So which means this one is true. We've got another rule, log rule, which of course we will use. Now, we've got another one, ln a over b is the same as ln a minus ln b. Again, let us test. If we had ln 3 over 2, is it going to be equal to ln 3 minus ln 2? Let's put it to the test, shall we? 3 over 2, it's 0,4054 651881. Now let's put ln 3 and subtract ln 2. As you can see, it gives us the exact same number. So which means this one is true. And then lastly, we have what we will call if you have ln A over ln B, it is the same as log. Remember, I said we are dealing with logarithms. Ln A base ln B. Let's put it to the test. If we add ln 3 over ln 2, is it the same as log 3 base 2? That's how you pronounce it. It's log 3 base 2. So, got ln 3 over ln 2 got 1,5 8496251. Now how do we press this log? You say shift. Now you will notice here, sorry, no, not even press it. You will notice here that there is this log with 2 squares. You press that log so that you can put any log number you want. So any log base you want. Then you put this, and you notice that they give us the exact same figures. So which means these are the log rules we'll be needing to apply. Now, when applying these log rules, I want us to note, most importantly for now, we are not going to note this rule. This is the rule we are noting at the moment. Now, after having established these log rules, we are saying we want to make that T the subject, but we want something that brings down that T. And log rule number 1 allows us, if we introduce that log, our A now becomes 1 plus I and our B becomes T. Which means applying log rule number 1, which states that ln A to the power B is the same as B times ln A, we now can make that T come down and be T. Sorry, come down and be a factor rather than an exponent. And now inside the log, we notice that there is now no more anything that has to do with T, meaning we can divide by that log. And this is the value of T that we obtain. This method of calculation will be very important to us when we do our equations, especially when we do univariate equations. I guess I'll see you on the next video when we do univariate equations. Thank you.